Hi, my name is Xinyu Huang and my net ID is XH1328. In this video, I finished my final report of the subway communication system and I will make a presentation of my project. And the first one is background, why I chose this topic. I remember when we learned the first lesson, the teacher cited many different complex systems, one of which was the subway. A subway is a transportation that we come into contact with almost every day. So I want to make a system engineering analysis on the subway system. In a variety of subway subsystems, I choose the communication in subway because I'm very curious about the communication way of the staff in the subway station, and also how can we observe the real-time information or other informations from the station. Besides, uh, we may meet some emergencies in the subway station, such as the fire or the terrorist. So we need the staff to tell us how to leave the sign as quickly as possible. So that's called the emergency evacuation. So there are many ways to validate the emergency evacuation, such as the broadcast and the LED board in the station or the telephone. Uh, so next part is need analysis. At first, I started with the subjects and I divided them into three categories. The first one is the operation of the subway, which include train information and the connect between the stations. And next one is the station staff. So as I said before, we need some surveillance video to watch the passengers. And when we meet emergency, the station staff should communicate with the passengers and tell them how to leave the sign. And the last one is actually the exactly the passengers. So we need observe real-time information from the station or from the staff, and we need the timetable or the route map of the whole subway. So we divided the subjects into three categories, and we can combine them and form the function we need. For example, the station staff need the broadcast to tell the passengers the real-time information or the emergency. And the passengers also need a broadcast to observe these informations from the station staff or the train. And next one is clock. I think all of the subjects need the clock. And there are many other functions such as business telephone, video surveillance, private telephone, and passenger information. I will illustrate them in the next part. And total and the power and the transmission function is the basic function that the subway communication system require. You need the power and also you need the line to connect each subsystem. And totally we divided the 8 functions of the subway communication system. 2 of them are basic and 6 of them are we combine the subjects we just divided. And the next one is needs validation. So in this part, I will illustrate the importance of each function subway communication. Uh, for example, we need the network interface management in the communication system. So we need to know how to choose the Ethernet or other internet And another example is cable. So there are many cables in the market. We need to choose the type which meet the requirements of the subway communication system. After that, we need to consider the cost of this type, and we need to choose the best one as the cable that we need in the communication system. The next part is concept exploration. In this part, I will describe the importance of each subway each function in subway communications system, and why we need them to build a complete system. Since I divided all requirements into 8 different functions, I can take 2 of them as example here and describes what problems can each function solve. And then we will check if they are redundant in performance requirements. The first one is the transmission function. This is the most important function in this system, as I said before, because it can connect each station and the traffic dispatching command center together. So other functions can feed back to the command center in time, and the staff will give different instructions for variable situations. The next one is private telephone. We need this function because subway stations may encounter some emergencies, such as terrorist attacks, fires, earthquakes. We just talked about this before. The staff need guide passengers, leave stations orderly and safely. Remember the emergency evacuation. So the station should have a telephone which will not affect by other telephones and emergency situations and play the role of disaster prevention and rescue, and also the accident handling when the station needs. And the next part is performance requirement formulation. In this part, I will translate 8 functions into 8 different subsystems of the subway communication system. And each subsystem can satisfy one function. So here I will take a private telephone subsystem as the example. So special telephone system is made up of dispatching telephone, standing between driving calls and the phone within the station. The station of 4 parts such as trains, dispatching command, facilities maintenance, simple contact between related staff to provide effective, reliable, and a rapid way of communication, and set up a chief dispatcher, coordinate and monitor the OCC train dispatcher, environment control, maintenance dispatcher, the dispatcher, power dispatcher, and the control operation. And the next one is a video surveillance subsystem. The system is mainly composed of station, vehicle, control center, and vehicle depot. So we need them to monitoring the environment of the whole subway station or the subway train. And the next part is implementation of concept exploration. Actually, I wrote all of technologies and the architecture the subway communication system need in the last part, and almost can easily achieve nowadays. So here I want to discuss about transmission subsystems technology, as noted above. This subsystem can choose both MSTP and OTN as transmission equipment. Uh, uh, Obviously, OTN is better than MSTP because it has higher bandwidth and lower delay compared with MSTP. Besides, it has high intellectualization of channel protection. But it's too expensive to apply OTN in all of transmission equipment in the system. So MSTP is widely used in subway and the transmission system currently. I believe this problem can be solved after mass production of OTN in our country. The next part is performance requirement validation. Since subway communication system has already implemented as a subsystem of the whole system and developed it with the progress of science and technology and the development of the times, subway communication become a very mature system today. So in this part, I will illustrate how to validate each subsystem we have just defined, but I'm not going to describe the irrationality in the system, which has been in operation for many years and will be updated with technology. So here I will take two subsystems as example. The first is a private telephone. The test of the operation of the telephone system is whether it can communicate normally, whether the signal will be affected, and whether it can communicate normally in an emergency. And the next one is broadcast subsystem. Uh, be able to make a normal broadcast and be heard from anywhere in the station is the basic requirements of this subsystem. In the event of an emergency, announcements can also be made and passengers can be instructed to evacuate the station. Okay, the next one is concept definition. So we have, uh, hold on. Okay, since all subsystems use Ethernet to networks, there is no problem with incompatible subsystem. What I want to discuss in this part is performance of each subsystem. So, for example, for a clock system, the only performance indicators are the same as a local standard time, and the same time for each station and the train. And for power subsystem, the only criterion is the ability to continuously power all the other subsystems of subway communication system, regardless of the circumstances. It is relatively easy to judge the performance of these two subsystems compared with others. When it comes to the telephone subsystems, both private and business, what we need concern first is quality of connection. No matter what happens, it is necessary to ensure that the telephone subsystem can communicate effectively, whether the station staff communicate with each other or need to contact external personnel. Moreover, if the train itself fails to run properly, the staff on the train also need to contact the staff in both stations in time to ensure that the next train will delay its departure so as to have enough time to deal with the current problem. The next one is passenger subsystem and broadcast subsystem. They should ensure that everyone in the station can get the information. The staff can contact each other with telephone subsystem, but passengers need broadcast or multimedia because the number of passengers is too great to transmit information by telephone in daily life. So these two subsystems are keys whether passengers can get timely and effective information from subway station or not. And the next one is video surveillance subsystem. It needs to be located in all of the key locations throughout the subway station so that it can be observed at any time. And it also needs to have a reserve function to play back previous video. I will discuss transmission system in next part. The next part is program cost. As I say, I will discuss about the transmission system because the item is by other subsystems are also easy to see in daily life, such as video, telephone, multimedia. There is already a good reference between price and performance. So there are two kind of transport devices in the transportation subsystem. They are MSTB and OTN, as we just said before. So the OTN with the development of science and technology, we need more and more information, which requires the transmission equipment to have functions of high bandwidth and low delay. And it also needs additional functions such as intelligent channel protection. So the transmission equipment should be overdone like OTN. However, the cost of OTN is very high and it is unique. The country can't produce the OTN but can only buy them from other company. Besides, it's very expensive. So I believe the OTN is only a possibility until the country can mass produce the device or develop a better transmission device to replace it. So next part is advanced development. I have described each subsystem's function in the previous article, so I want to discuss about these functions specifications from operational and performance requirements and how to translate these functions into component requirements in this part. For example, the transmission subsystem is the most important subsystem, and I said it before. So if the transmission subsystem fails, it is likely to bring multiple subsystems down. However, it is a simple subsystem and same time because what you need to do is choosing a transfer mode and connect other subsystems correctly. And another example is broadcaster subsystem. I illustrated it in my paper, so I will not repeat it here. Next part is engineering design. In this part, I will illustrate subway communication systems from three characteristics of it: reliability, maintainability, and producibility. Since I can't find some exact data about the failure probability of communication system, I cite the failure times of a subway line in a month and the reasons of them to study the characteristics of communication system. And the data is the table shown in the slide. So from July 1st to July 31st, this subway line totally occurred 12 failures in the station and center. So you can say 3 of them are from video subsystem, 5 of them from telephone, and 2 of them from Wi-Fi. Passengers information subsystem and the broadcast subsystem each failed once. So from the data, we can obtain that reliability of communication system is very high because the line needs to run for more than 527 hours in the whole month, and it just occurred 12 failures, and most of them are computer crash, and these problems can be solved in few minutes. So this number of failures is from the June, and we can say their total is 31. Okay, so that's what I want to say is the maintainability of this subway. As the table showed, the number of hours reduced in July. This, so you can say from the 31 to the 12 in the communication system, and from the 191 to 116 in total. So this is a subway station that has just started operation, which indicates that the maintenance personnel can find out the cause of failure in time and solve the problem within 1 month, which indicates that the subway signal system has good maintainability. So next one is producibility. Well, when it comes to producibility, I think it is not a problem to subway communication system because almost of the components of each subsystems can produce in large quantities and low production costs. Stations can replace 40 parts at any time or refresh the old component. So next part is integration and evaluation. Also, as we said before, the subway communication system has high reliability and the high maintainability and the good producibility. However, it also have some disadvantage. Compared with the ground environment, the environment of subway is more gloomy, cold, and humid, which is a huge challenge for the lines, computers, and servers needed for communication, and also the main reason for communication failures, as as we discussed before, the computer crash. So this is the main problem of the subway communication system. The next part is high priority areas for operational test. First of all, we need to discuss about the new features of the subway. Apparently, the existing subway communication system is stable and errorless, but we need to use new technology into the subway under construction. For example, we just talked about the driverless technology, but we need to consider about the GOA. So they have 5 levels. To realize the driverless technology, most of existing subway can't do this because it's just in GOA 2, and we need to change them into GOA 4, which can support unmanned subway trains. I think our subway system will eventually become driverless because as the number of subway lines keeps increasing, the demand for train drivers will be in short supply, and the driverless assistance will surely be needed then. And so we need to face some environments such as fire, typhoon, and earthquake. These disasters are deadly to the communication system, so we need to build communication systems that take into account the location of the subway station. So, for example, in cities with typhoons, subway lines should be built underground rather than on the ground, and equipment for flood control and drainage should be built. And also, subway lines that might be in danger during a typhoon must shut down. Okay, uh, sorry. The next part is production. And about production planning, since the production of subway communication system in China is run by the government, so unfortunately I can't get the complete and comprehensive plan online. So I will describe the responsibility for each major component, manufacturing facilities, and the tooling requirements, including special tools in this part. So the first one is transmission subsystem, and in this subsystem, it will divide in 2 parts. The first one is communication transmission line. So the communication transmission line is cable, and actually most of country now use cable from domestic some large manufacturers. In China, they are Shenzhen Optic CO and Shanghai Huaxin Wire and Cable CO and 514, such as this company. And the next one is the transmission. The next one is the communication transmission equipment. So they are from the Corning and Incom. So both of them are foreign company. And the communication transmission equipment are from the in China from the Huawei, Shenzhen Huawei, and also some of them are from the Siemens AG in the Germany. And also we can build some new technology equipment from the Wuhan 722 Research Institute. The next one is private telephone subsystem. Also, I will discussing into them in two parts. The first one is dispatching telephone. There are two kinds of telephone dispatching. ENE is collinear to wire simplex mode. The equipment in this way generally adopts a DC programmed control dispatching equipment produced by Beijing Railway Communication Engineering in China, which is a mature product. Another one is a radiant point-to-point through call. The ZKD series programmed control communication equipment produced by Shanghai Huacheng Electronic Communication. And the next one is station telephone, and there are only one company is the Beijing Steven Communication Equipment, and their equipment is the Campact type. And the third subsystem is the business telephone. As a subway business telephone network can be composed of single or multiple units according to needs, which are composed of central telephone centers and sub-telephone units. And the company that can generate the equipment are similar as the private telephone subsystem, as I described before. So next one is a clock subsystem. Generally, the subclock chain scheme is adopted, which consists of satellite global position system time standard signal receiver, central clock, secondary clock, monitoring system, sub-clock, and other parts. So the main company in the China is the Yantai Watch Research Institute and the Xi'an Watch Research Institute. And the next one is broadcast subsystem. So they are from the Shanghai Xingya Wireless Power Plant and the Shaoyang Wireless Power Plant. And the next one is video surveillance subsystem. The station dispatcher can choose all stations to line directly in the center into the image before the video image signal in transmission to the control center using video compression or reuse. And the main company is the Third Research Institute of the Electronics Department and the Huanan Photoelectric Instrument Factory. And the last one is power system. Subway communication equipment shall be powered by first stage load, and the DC power supply of communication equipment adopts 48 power supply. The next part is complex factors. In this part, I will describe advancing technology about the subway communication system and analyze its areas that needs to be lifted and tested. The first one is we mentioned several times before, the driverless subway. So automatic driverless system is completely not involved with the driver and crew. The unified control of the vehicle in the control center to realize automatic operation, automatic sleep, wake up, preparing, self-check, automatic train operation, parking and switch door, and realize a function such as automatic recovery under fault condition, including car wash, can also be completed in the case of unattended operation. So this is a very great technology, but we need to test them several times. And another one is a human-computer interaction. Sorry. The another technology is the human encounter computer interaction. So software interface is information interface between man and machine. In a sense, it is more important than hardware and environment. When we take the subway, are we still sorry that we can't see the scenery outside? To this end, the new generation of subway cars will try to integrate a 55-inch OLED display film into the windows, allowing passengers to watch videos online from all angles and plan their route and search for information on the display. In addition, there are more user-friendly designs that can be applied to subway. We can design the 3D binocular camera above the door so that the number of passengers on the train can be automatically accurately calculated so as to determine the passengers crowding index and guide the passengers on the platform to take the train. Because such a camera itself can increase the statistical accuracy of the number of people according to the test accuracy is more than 98%. In addition, we can achieve full coverage of Wi-Fi signals and is equipped with visible light wireless communication. And the next technology I want to discuss is LTE. LTE stands for 3GPP long-term evolution. LTE, also popularly known as 3.9G, has a 100 data download capability and is seen as the dominant technology, evolving from 3G to 4G. LTE system adopts flat wireless access network structure without RNC node. We can apply this technology into subway communication. So the first one is using LTE communication technology. That it has better than Wi-Fi channel structure and better performance. The next one is rail transit has a higher requirements for operation security and it requires a lot of video. So we can use the LTE technology to do these things. And next one is applied to the underground wireless communication. It can get a higher rate of download and upward efficiency. For example of the LTE is the first train that used the LTE technology in Zhengzhou, and it is very successful. The next part is operation and support. The first I want to illustrate the system is installation. So subway communication system requires significant effort for installation because the subway signal system is built with the whole subway at the same time. You have to decide at the beginning what communication technology will be used and how to connect the transmission line. It is usually impossible to change the whole signal system in the running subway station. First of all, the whole line must be shut down. Second, the signal system that has been built before needs to be replaced with a new one. In this way, it will consume a lot of manpower, material resources, and financial resources, even if it affects the traffic of ground cars. So the next one is significant test and component replacement. The subway communication system also needs routine maintenance, repair, and replacement of equipment. I have explained this part in detail in the paper. The next one is major upgrades of large complex systems. Here I give the example of technologies to be applied in the Beijing subway, such as the face recognition system, which enables passengers to quickly pass the verification to get in the station. And the screen in the subway can also realize human-computer interaction. So this is the face recognition machine. And the next one is the fast fall detection. So, for example, the first one is the train enters the main line from the depot. So we have the test method, and we can detect the fault quickly, and we can repair or replace the equipment. The next one is the train enters the depot from the main line. The third one is train reentry and storage. The next one is train location change. So the next one is the fifth is the change of automatic train number or driver train number, ATS train number. And the next one is manual train number input. So here is a test method. When the traffic dispatcher inputs a train number, train service number, and the train number, the train number is changed to the input train number. The wireless number of the head car, the wireless number of the tail car, the crew number, and the current line number are unchanged. And the signal system ATS sends the M-type message to the wireless subsystem when the train turns back. The seventh is the manual train number delete. And the last one is ATS generates fault number. And the system for the challenge of the whole topic, since the subway communication system has existed since there was a subway, and it has been quite perfect after many years of updates and iteration. So when I was writing this paper, many parts were particularly difficult to describe or find information, such as the program schedule. I can't find the price of the current metro communication system and other equipment they need. And another one is a risk in achieving each of the above. So just as I said, I can't find the exact data of the fail possibility. So I just can analyze the the error occurred in the whole month as the table we just showed. The next one is choose text, because each system facing the condition is different, so you need to choose their own from the textbook paper to choose the useful subjects, and at each stage to consider the need to write is become very difficult, such as the need to provide time and the factory production parts. I find a lot of information, but it is hard to find the specific needs. How much time each city subway construction progress is not the same. And in the terms of the support, each station is also a lot of poor, such as the nearest subway station in the direction of the accident maintenance point, how far. In addition to the subway is convenient transportation, and about how many times they need to repair or replace the broken equipment. The last is summary and lesson learned. So we use the system engineer to analyze the whole big complex system in this topic. So I have learned the basic system engineering theory through this course. And we know at first this is a complex system. We need to divide them into the several subsystems, and through the subsystems we can divide them into components that require the meat of each subsystem. Like I said in the challenge, some wielded such as each equipment in detail of cost control. Each subsystem needed to set up time, testing, and maintenance time. Each subsystem failure probability in detail, and so on. All of these are almost no data on the net. I can't find the information. Only by other papers to derives the most basic theory and information. So most of uh, the view of this paper is I analyze the analyzation from other papers of the some paper report from the communication subway communication company or the paper report from some uh, maintenance company. But this information is enough to make me have a general understanding of the subway communication system. Also know how to build, test, operation, and maintain the complex system in access to data and writing thesis. I also found many articles about subway possible future development of technology. The technology also makes me a lot inspiration about the subway in the future. And I believe the most of the technologies will be the real shortly after put into use in the subway. So this is my presentation. Thank you.